I'm going to do problem 16 in section 3.3. Problem 16 says that we have 2 times the square root of 50 x squared minus 8x times the square root of 18 minus 3 times the square root of 72x squared. And we're asked to combine the following expressions, and we're supposed to assume that any variables under an even root are non-negative. So what that means is if numbers are non-negative, that means that they are positive. So non-negative, oops, going off the paper here. It just says non-negative means positive, which means no absolute value necessary. So that's a good thing. We don't have to worry about whether they're positive, negative, or whatever we're doing. Okay, so now I'm going to go back. And to be able to subtract these radicals, they need to have the same index and the same radicand. So to subtract, radicals must have same index, that's the number in the crook, and same radicand, that's the numbers under the radical. So looking back at these radicals, we have the same index. It's understood to be 2. Under the radicals, we don't have the same radicand, not even remotely close. So I'm going to go back and I'm looking at these numbers and I'm thinking, well, I wonder if I could simplify them. And the easiest way to simplify these for me is to look at the numbers and figure out the factors of those numbers. And think of factors of these numbers for 50, 18, and 72, each separately, that are perfect squares. If you do not know the factors of 50, then you're going to have to resort back to your prime factorization. So I'm going to do it with using factors that are perfect squares first, and then if need be I'll go ahead and do it with using prime factors for those of you that might need that help too. So looking at this, 50, well, I know that 25 is a factor of 50, so I'm going to rewrite this as 2 square root 25 times 2, and then the x squared is just going to go along. 25 is a perfect square, so that's good. On the next radical, factors of 18 that are perfect squares. I'm going to use 9, and then what's left over? 2. On the third radical, now I could use 9, so let me write this down. 9 is a perfect square, but it's not the biggest perfect square that is a factor of 72. So it is a perfect square of 72, but 36 is a better perfect square. So we'll just write down is a bigger perfect square factor. So I'm going to rewrite this then as 36 times 2, and the x squared goes along for the ride. So I could have used 9. That's not the ideal one. And again, if you don't see that, we may need to do some prime factoring. Okay. Actually, I could probably show you what it looks like if we do 9. Let's do it the best way first, and then I will talk about some of these other ways. Okay, so if I take the square root of 25, it becomes 5. That 5, when you bring it out, is going to be multiplied by the 2. Anything that I bring outside the radical here is multiplied by whatever number I have outside here. So I'm going to bring out the 25. The x squared is also a perfect square. The index and the power are the same, so I end up getting just an x. So what haven't I taken care of under the radical? The 2. The next problem. I have 8x outside. The square root of 9 is 3. That's going to be multiplied by my 8x. What's left over underneath? 2. Minus 3. Square root of 36 is 6, and be multiplied times that 3. The x squared can come out. When it comes out, it becomes just x. And I have a 2 underneath. I'm going to simplify all these coefficients in front of my radical now, just by multiply. So 2 times 5x is 10x. Minus 8x times 3 is 24x. Minus 3 times 6x is 18x. Square root of 2. Ooh, cool! Look at what I have here. I have the same radicand now. So all I need to do is subtract my coefficients. So I'm going to kind of write this a little bit differently than I have been doing in class. I'm going to take all my coefficients, 10x minus 24x minus 18x. I'm going to combine all those guys together, and then they're just going to have the square root of 2 that they'll be multiplied by. So now I need you guys to take 10x minus 24x minus 18x and figure out what do we end up simplifying that to. Okay, should be coming up with negative 32x square root of 2. That is the answer to problem 16. You are done. Okay, so let's go back and answer some of those questions that maybe you had forming in your mind. Let's go back to this first question here where we have a 9. So I'm going to do the same problem now. Put a little break here. And I'm going to go back up to this previous step, this step right here. And I'm going to write that last radical a little bit differently. So we're still going to have 2 square root of 25 times 2x squared minus 8x times the square root of 9 times 2. That was factoring 18. And then 72. I said, well, what happens if you don't realize that 36 is a factor of 72? It's not, and instead you come up with 9. So let's just put in a 9 here. 9 times 8 would give me 72. Okay, so now let's just go through the next step. We're going to pull out our 5. We're going to pull out our x. We're left over with the square root of 2. On the next problem, we're going to pull out a 3, and we're left over with the square root of 2. On the next problem, I'm going to pull out a 3, multiply times the 3 I already have, pull out an x, and I'm left over with the square root of 8. So remember, for us to be able to combine anything, we're going to want to have all the same radicand. Do I have all the same radicand? No. You could combine these two guys together once we simplify. You need to realize that 8 has a factor that is also a perfect square. So when we go through this next step, I'm going to simplify here. 2 times 5x is 10x. 8x times 3 is 24x. 3 times 3x is 9x. And then this 8 right here, remember we have factors of 8 that are also perfect squares. 4 times 2. So it's going to take me another step. And that's okay. But you need to realize that 8 has a perfect square in it. And it's not simplified as much as it possibly can. So if you don't see that 36 is a perfect square, it's not the biggest perfect square, if you found 9 instead, it just means you're going to need to do another step here. So I'm going to go ahead and finish up this step here. We have 10x square root of 2 minus 24x square roots of 2 minus 9x times square root of 4 is 2 square roots of 2. So we have 10x square roots of 2 minus 24x square roots of 2 minus 18x square roots of 2. And again, when we add all those up, what do we end up with? Negative 32x square root of 2. Same answer. Whew, good thing. So again, you're looking for perfect squares. You want to find the biggest one. If you don't, you may have to make sure that you have everything simplified as much as possible. So whenever you end up without having all the same radicand, look at the one that's different. Make sure that you can't simplify that further. Okay, so I'm going to do the same problem. So if you think you understand what's going on, you think you're okay with this process, good. Go ahead and you can stop the video. But if you don't know your factors of 50 or 18 or 72 really well, this is where the prime factorization comes into play. So I'm going to take 50, 18, and 72, and I'm going to prime factor each one of them. So 50, prime factors of 50. Remember, we're going to start with the smallest prime factor that can go into 50. That would be 2. What do I have left over when I take 50 divided by 2? 25. 25, can I divide it by 2? No, because it's not even. Can I divide it by 3? Well, 3. For it to be divisible by 3, I have to be able to add my digits, 2 and 5, which equals 7. Is 7 divisible by 3? No. Therefore, 25 is not. And you guys have your calculators. You can figure that out. 25 is not divisible by 3. Next prime number I'm going to try is 5. And 5 is divisible, or 25 is divisible by 5. So my prime factors for 50, 2 times 5 squared. Prime factors for 18, starting off again with 2. 2 does work. 18 divided by 2 is 9. 9 is 3 times 3. Prime factors of 18, 2 times 3 squared. And then the last one I'm going to do is prime factors of 72. And again, I'm going to start off with 2. 72 divided by 2 is 36. 36, I'm going to see if I can divide that by 2. I can. 18 divisible by 2. 9 divisible by 3. So my prime factors for 72, 1, 2, 3. 2 to the third, 3 to the second. So I'm going to go ahead and rewrite this original equation up here in prime factored form. So again, I'm starting down on this step right here, but instead of having perfect squares as my factors, I'm going to have my prime factorization written in. So this line right up here that I have in red, it's going to be the same thing down here, but now I'm going to be writing it in prime factors. So I have 2. Instead of 50, I'm going to write it as 2 times 5 squared, x squared, minus 8x, using my prime factors of 18, 2 times 3 squared, minus 3, using my prime factors of 72, 2 to the third, 3 squared x squared. Okay, so now I'm going to look for any powers that are more than my index. And remember, my index is 2. So wherever I have a power of 2, I can bring out 1. Over here, I have 2 to the third. Oops, 2 to the third. I'm going to bring out a 2, and I'm going to have a 2 left over. So rewriting this then, I'm going to have 2. I'm going to bring out my 5. I'm going to bring out my x. And I'm going to have a 2 left over inside. And I'm going to have 8x. I'm going to bring out a 3. I'm going to have a 2 left over. On this next one, let me write above here. Those with it using prime factorization might also have a little bit of difficulty with this. I'm going to rewrite this. Instead of 2 to the 3, I'm going to write it as 2 to the second times 2 times 3 squared x squared. So why did I do that? So that you can see that 2 to the third is the same as 2 to the second times 2 to the first. So I'm going to bring out a 2, a 3, an x, and I'm going to have a 2 to the first left over. So with the 3, I'm going to bring out a 2, I'm going to bring out another 3, I'm going to bring out an x. What am I left over with underneath? 2. Multiplying all these together, 10x square root of 2 minus 24x square root of 2 minus 18x square root of 2. And now we're where we were with all these other problems, and this equals negative 32x square root of 2. So a couple different ways of doing the same problem. First method uses the biggest perfect square. Second method uses a square that is a factor and then having to simplify again. And then the third way that we did it was using prime factorization.